In this video, we will learn about numeric data types that are available in Python. See, this is the list of data types available in Python, that is integer type, float type, bool, and complex. We will learn about all these one by one. Let us take integer first. Integral values are the numeric values without any decimal point. For example, a value 125 is an integral value. A value that is 2164, this is a integral value. So there is no decimal point here, there is no point. These type of values are called as integer type values in Python. And we can have these values stored in some variables. Let us say a assign 125. So the value of a is 125 and value of b is 2164. The next thing is, we can also have these integral values in negative form, like negative integer values, like -17 is a negative number. So integer allows both positive as well as negative type of values. Now the next important point about integer is there is no size limit or there is no range for integer value. Suppose I am taking a variable x and here I want to store some integral number like 125973. Can I store this much lengthy number? Yes, Python allows you to store a number of any size. So this is amazing. If you are coming from other programming languages, you may be knowing that this much lengthy numbers are not allowed in the data types, integer data type. But here in Python, you can take a number as much large as possible. So you can take a number of any size, any range. Now, the next thing, you may be thinking, how much memory does this integer data type takes? So there is no fixed size memory taken by any data type in Python. There is no fixed size. Like if I talk about other languages like C and Java, C or C++ and Java, then there you may be knowing that integer takes 4 bytes, right? If you are coming from C, C++, Java. If not, then don't worry. I'm telling for the person who already knows some language. But here in Python, there is no size limit for the memory for any of the data type. So that is the reason it allows us to store the number as much large as possible. So let us check this larger number. Let us try this number and check once. I will go to ideally. Here I will take a variable a with 125. I want to know the type of a. You can see that type of a is integer. Here it is showing it is integer. Now I take one more variable b with 2164. This is also an integer. Can I take a variable x and I will store the values? See, I have taken a very big number. It allows. And if I say print x, it will print the value of x. Yes, x is containing that much larger value. Now does Python allow negative numbers? I will store a value -17. If I say y, yes, it is storing value -17. -17 is there in y. If I just type the variable name also, it will print. Print will also print the value in the variable, as well as just if you give the variable name, also it will print the value. Alright. Now next thing, if I print x dot underscore underscore size of underscore underscore brackets, then let us see what it will print. It is printing 40. So it means the size of variable x is 40. I have stored such a lengthy number in x and the memory consumed by this x is 40. So you can use this size of function for knowing the amount of memory consumed by any variable. Let us check what is the amount of memory consumed by variable y. So print y dot underscore underscore size of underscore underscore and brackets. Yeah, it is taking 28. So for this value -17, it is taking 28 bytes. And for a larger number, x is taking 40 bytes. So that's it. I told you that the amount of memory taken by integer data type is not fixed, right? It depends on the number size of the number that you are storing in it. I'm storing a smaller number, then it is taking 28. And in x, I have a very large number, so it is taking 40 bytes. Now, if you want to know why is taking 28 bytes, If you want to know what is the reason it's taking 20%, so don't worry about that, because Python treats everything as an object. So it has its own policy of consuming memory. So it is not like other languages where the size of the memory is fixed for data types. Now, next thing about integer. The thing what I am going to explain is common for most of the data types in Python. The interesting thing is, if suppose I have a variable a and I am storing value 125, the same thing I am repeating again. So what happens in the memory is a is a variable and it is a reference to the value 125. So 125 is stored in the memory, variable a is also in the memory, and this will be referring to this one. This is how it looks like. A is a variable referring to the value 125. Now the next moment in the program, in the next moment, if I change the value of a to 200, then what happens? Will this value modify? Will this value that is 125 is modified to 200? No. It will create a new value that is 200 and store it in a separate memory area, and this a will not be pointing here. It will start pointing at this location, right? So a is no more pointing to 125. A is pointing to a new object with value 200. So the point here is that when we change the value of a from 125 to 200, so actual 125 is not changing, but a new value is creating. So can we change this value 125? Is it possible? No. So the value is immutable. So immutable means value cannot be changed. So yes, in Python, whatever the value or data that you are taking, it is immutable. It cannot be changed. If you want to modify, instead of changing the value, it will create a new value. It will create a new value, new object. So this is the very important thing in Python. Most of the data types are immutable in Python. Instead of modifying the existing data, it prefers creating a new data. So the reason behind it I will tell you. Suppose you are living in a house and it is now old, very old house, 50 to 60-year-old house, and you want to renovate the house. Now you tell me, constructing a new house at a new place is better or renovating an old house is better? What is better? Which is easy? So constructing a new house is easy. Don't go on the cost, right? I'm talking about the work done. So renovating a new house may have more challenges than creating a new house. So that's why Python prefer that, creating a new object instead of modifying the existing object. So most of the objects are immutable. That's what we say, immutable. So remember this term, you will come across it at many other places whenever we learn other data types. So what happens to this value that is 125? So this object will be garbage collected by PVM. So it is gone from the memory, and a is pointing on this new value or the new object. So that's it. So we have learned few things along with integer data type. We have learned that integer data type can be as large as possible, and we have learned that it can be positive and negative. And next thing we learned that it is immutable. All other data types are also similarly immutable. Let us go to float, bool, and complex. Let us learn about these data types. A floating point value. So any value that is having a decimal point, like 13.25. So this is having a decimal point. So this is called as floating point number or a decimal number. Float numbers can also be negative, like minus 17.66. So this is a negative floating point number. Floating point numbers can also be represented in scientific notation. Let us learn a little bit about scientific notation. Suppose I have a number 12.59. It can be written as 0.1259 into 100. So it means if I multiply this number with 100, so decimal point will move to this place, right? So this can also be written as 1259 into 10 square. 100 is nothing but 10 square. So this can be represented scientific notation like 1259 E2. E means 10 to the power. 10 to the power 2 can be written as E2. So this E2 means 10 to the power of 2. So this decimal point is moved to the front of the number before the first digit, just before the first digit. So we are moving this decimal point and representing it in scientific notation. So this moving of decimal point is also called as floating of a point. So that's why this representation is called as floating point representation. Even this number 12.59 can be written in some other way. I'll show you this one. We can move this floating point to the last digit after the last digit. So this can become 1259.0, and this is divided by 100. And this is nothing but 1259.0 divided by 10 square. And this can be written as 1259.0 into 10 to the power of minus 2. So in scientific representation, we can write it as 1259. Now, no need of writing decimal point now, because after decimal, there are no digits, just we have 0. So no need of writing any decimal number, just 1259, and this is E minus 2. So there are two ways of representing this 12.59. We can write it as 0.1259 E2, or also we can write it as 1259 E minus 2. So here no decimal point is required. So mostly this is the representation used. So floating point numbers can also be represented like this in Python. So I can store a value in variable x like 1259 E minus 2. If suppose I want to store a number minus 12.59, then it can be written as y is assigned minus 1259 E minus 2. So now you can see that the value before E is also negative and the value after E is also negative. Actually, the value before E is called as mantissa. It is called as mantissa, and the value after E is called as exponent. So this is scientific representation. So I have explained you what are floating point numbers. Any number having decimal point is a floating number. They can be positive and negative also. And this is the scientific representation I have explained for the floating point number. You can use this scientific representation for representing your float number, right? So now next thing is how much size or how much memory does this floating point takes? What is the range? There is no limit. You can take the number as much large as possible. So just like integer, float also doesn't have any size limit, any range, and float data type is also immutable, right? Let us look at the demonstration for this one. I'll take a value a, variable a, with value 12.59. Now if I say a, I get the display, and that is 12.59. I'll take variable b and I will make it as 1259 e minus 2. So if I print b, see what I'll get. I'll get the same number. So I have represented a floating number using scientific representation, and even I can use it like this: 0.1259 E2. See, you can use E in small letter or capital letter also. Now if I print C, I'll get the same result, that is 12.59. And if I take a variable x, now 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Can I take a larger number? Yes, you can take the number as much large as you want. And if you want to know how much size a variable x is taking, just you can say underscore underscore x dot underscore underscore size of, then underscore underscore brackets close. Now it is taking 24 bytes. Alright. So if you have a very large number, then this number of bytes may be increasing. So that's all about float data type. In the next lecture, I'll explain about bool as well as complex data type.